Welcome to Learning with Gilb, and today I am so lucky to have Raul Gomez with us. And Raul is a consultant with Construct Metrics, and he's currently heavily involved in Internet of Things USA, and I'm sure he'll tell us all about what he's doing there a little later. Raul has a passion for BIM and CAD and VDC and AI and sensory, and he has extensive experience in design and construction industries. He plays a significant role in helping businesses with profitability and growth and aids in the digital transformation of the future of modern construction. Welcome, Raul.
Thank you, Kai. Pleasure to be with you, and I appreciate the invitation.
Yes, pleasure is all mine. We want to dive into all of these things, BIMs and sensors, etc. But before we go there, so you have this intersection between construction and technology. Why don't you take us back to where that started, both construction and technology? How does that start for you, that interest and as you say, passion?
Well, that's a great question. And I'll go back some years, and I don't want to date myself here, but I started in an era where manual drawing and manual drafting was a thing. Having been at a very young age, CAD was introduced to the architectural and engineering field, and at that time, I was at a company in Chicago, and there was a lot of resistance for at least the older generation to utilize a computer-aided design system. Being young, I was very interested in learning it and using it, and when I did, I was probably the first one at our firm, which we were a design build firm, to use it and learn it. And just like today, you know, there's always resistance to change, depending, you know, what you're doing. And that's really a human reaction, and that's really what occurred then. And I embraced it, I learned it. Once I began working on projects, my own projects on CAD, and began doing them faster, quicker, more efficiently, even, you know, neater. Obviously, it wasn't done by hand, it was done by a computer. I was asked by the leadership of the company to expand the program of CAD within the company, and I sort of became a CAD trainer, and then I became a CAD system manager by default, even though my background was architecture. And really, since then, I haven't looked back in terms of applying my background in schooling and also really design. It's all been really figuring out ways to improve, at least at that time, the design environment. How can we design better? How can we draw better? How does three-dimensional affect what we do? And I was doing 3D back in the 90s on systems that were fairly pioneered systems like Intergraph and Bentley back then. And then really, as we entered the new millennium 2000, was when Revit came along, and I was invited to participate with about 20 other people in Waltham, Virginia, to actually look at this new system, this new program, along with the developers. Felt very privileged to be there. And once I saw the power behind Revit, the parametric technology, the smart geometry, the information that you can now manage within that program, and then automatic 3D models, that was really a no-brainer for me to evolve into that system and into that technology, to the point where every time I was trying something new and I was trying to remain ahead of industry, many companies and many people that worked around me were always resistant to try to move to the next step. And that happened as well, going from 2D CAD to 3D CAD, where you had a lot of sort of CAD loyal AutoCAD people or MicroStation loyal CAD individuals that didn't want to make a change and that wanted to continue to support those platforms. Me, I stuck my neck out to a brand new startup company by the name of Revit, and I was working at AECom at the time, and I remember having our monthly meetings with other CAD managers in the company, and I was introducing Revit. And as soon as I did that, my next visit was to the CEO's office, being questioned why I was putting in a different platform into the mix. We had AutoCAD and we had MicroStation, but both platforms could not come close to what Revit was doing at that time. And right now, to me, the information that is actually built into a Revit model is really the most beneficial, I believe.
Hold on 1 second. Now you're talking about today, 2020.
Yeah, 2020, 21.
21.
It's really, it really, the model intelligence really began getting, I would say, better and better as architects and engineers adapted it more. And not only that, but they also adapted it better practice, like better modeling practice. We all know we can sit here and model things, but if we don't model with best practice in mind, sometimes the results that you get from a model are not that accurate. But I can easily say 5 years ago, we were pulling bill of materials or quantities from a model where we can utilize about 60% of that data right out of the model without having to go back and count how many doors do we have, how many windows do we have, what's the lineal footage of carpeting that we have, what's the square footage of drywall that we need. All of that was low-hanging fruit from the model itself. And I say 60% because there's no such thing as a 100% completed model. It would be like saying, here's 100% CDs, and that's a perfect set of drawings. It's never to the point of perfection, but from a 60% standpoint, you can at least pull out enough information where you're 60% more efficient as an estimator, and you have that information, and you no longer have to really go back and do it the old way of actually literally highlighting a set of drawings to do estimates.
These things exist, but what doesn't exist that would be great enhancements to the construction, the people working in construction, the builders and the
Sure,
engineers?
yeah. Well, that's what leads me up to what I'm doing today. Just because I've always been very passionate, Kai, in trying to improve the process. I've always wanted to work with people in the industry that are innovators. Assemble Systems was an example. I was going to mention Autodesk Point Layout. That's actually taking points from a model to a robot in the field and then linking your model with the field. So nobody has to use any tape measures. The robot is actually locating where parts of the building are going to be when you actually build a building, i.e. a footing or a wall. You can pull those points out from a model. So all of that is what I call sort of an evolutionary process. Now what's happening is that, we're using great SaaS systems to manage information, manage metadata from the model, manage construction documents, manage safety documents, manage all sorts of different elements. And there's many platforms out there, and you probably know many of them. Graphmetrics obviously being one of those, and you have Procore, you have BIM 360, you have all sorts of different SaaS systems. So now we're managing the data that's brought to us during design. We're actually managing the data in those environments to coordinate and to communicate, create RFIs from a model, etc. But now the missing piece is, once everything is already modeled, you have your design documents, your construction documents, your coordination models that you've assessed on correcting, but there's a disconnection now when we go into construction. How is that information coming back? Where is that information going? Do we track what's being built, and do we compare it against what we coordinated? The answer is, in many areas, no. So we depend on the eyes and ears of people in construction to keep up with the way things are supposed to be built in a certain way. And they're carrying around iPads, looking at a model, looking at a physical object, but there's really no correlation as to how to get that information back into the system to be able to compare what we actually coordinated and what's supposed to be built. Now, there's companies, larger companies, where they are now using 3-point cloud scanning capabilities to go out on a daily basis to scan. However, that is really heavy lifting, and it's not a inexpensive option. It can be pretty expensive. My goal has always been, how do we make it easier on the job site? What can we do now to make the job site more efficient? And how do we tie and correlate what we're doing as modelers, as coordinators, as virtual construction individuals to perfect the model and to build from, but how do we get what we're actually building back into the system to be able to assess what we're doing?
So let me just see if I understand. I think I understand you, but so what you're saying is, with these tools, we build, we design the systems, we maybe present it in 3D, and then the construction engineers, they go and they build, but they don't input back into the model. So they just build, they have the drawings, the specs, what they need, and they build it, but they might build it somewhat differently, and that information does not go back into the model. Is that how I understand you?
Well, that's been the challenging part, is that
Right.
if we call it as-built here, and a lot of times we don't get as-built information back quick enough to be able to analyze or maybe readjust what we're doing. For example, if I were to go out and scan a data center being built, for example, and if you imagine data centers, it's pretty heavy on mechanical systems and MEP systems in general. If I go out and scan with a traditional scanner, today I'd have to go out with a Trimble unit or something like that, scan the space. I will have to then take all my points of scans, pull it into a software, make sure it's registered correctly. In other words, make sure all the scans are correctly located in from a spatial standpoint, and then pull that into a Revit model or some kind of viewer that I can see, oh, the ductwork is 1 foot over than it's supposed to be. Now that 1 foot over is going to interfere with my fire protection main, or it's going to interfere with something else that is supposed to be there in the future. Now you can actually react to it. Now you can say, oh, wow, he moved this over 1 foot. What are the impacts? What do we need to change? Can we react to it? Or is it just easier for him to move it back to where it was supposed to be? At least you can assess, at that point. And that's really, the companies that are doing that right now are really on the edge. They're really innovative. It's almost, you've now introduced not only coordination, but you've introduced what's being built, and you're coordinating against what's being built versus what you coordinated. That is a huge leap forward in construction. However,
I think that's a great bridge to what I understand Internet of Things USA are doing. Maybe why don't you tell us what you're working on
sure,
with them?
I'd be happy to. So this is the area of construction, as I mentioned earlier, has always been sort of an island on itself. And we're trying to get them involved in utilizing technology, I think, is where technology needs to live. That is really the most important aspect, I think, of the construction cycle. And really, the goal, I think, that I am trying to push here. All right, can you see my screen there?
Yes, sir.
All right. So
Internet of Things USA.
Yeah, so this is again my passion, really trying to make an impact in the industry, and my goal here is to be able to take it to the next step, and that's really what I'm involved with here currently with this company. And we have a system called the MMI, which is a multi-mode imaging system. Really is what we're doing here. We don't need to talk about me, but this here is a multi-sensory AI-driven robot. And the goal here...
It looks like something on a theme park, or like a disco.
It does. You're right. Who knows? That may be a good industry to get into as well. But no, this is actually examples of different sensors that we have on here. We have infrared sensors, we have gigapan imagery, we have Ultra 8 type level sensors, we have LiDAR scanning, we have automated 3D scanning as well, structured lighting scanning, and multi-view stereo 3D mapping. These are all different sensors that this unit will be doing at one time. These can be mounted. They can be mounted on robo-dogs. They can be mounted on steel, on poles, all sorts of different options to mount them. And the difference is with this versus what we're doing today is that an owner would program what he wants to see. So if an owner says, I want my sensor unit to track everybody that's coming into the job site to make sure they don't have a temperature. Okay, that's addressing COVID. That's making sure nobody has a fever. I also want...
So this sensor can do that in addition to the building?
Yes.
I mean, it mainly is for building, right? But now
yeah, it's for building. Yeah, but it's
sensor.
Also for everything else that a job site would entail. So you have employees, you have safety, you have, maybe you might want to track your material out of as it enters the job site. You want to track vehicles, et cetera, et cetera. And
talking about vehicles, so I'm following Tesla a little bit and Elon Musk, and they're talking about not having so many different sensors. They just want vision, and this the radar and LiDAR and all those things. They're saying, for whatever reason, it's I'm not technical enough, but they're saying that's too much noise or something. It's better just to have vision.
Yeah, well, Tesla, I think that's a different animal there. A lot of the technologies that they're saying you can't really depend on that technology for autonomy of a vehicle. That's a difference. Here, you can depend on it because this information is not, you don't need this information as fast as you would for a Tesla. So
right, it's a different use case here.
The use case is on a construction site. It's a little different, but everything that you're seeing on the screen, this can do. So the way I look at this unit, not only with sensors, but it has cameras, and not only that, but we have AI running on the cameras. In this case that you're looking at in front, is that it's also monitoring a dumpster. So you no longer have to send someone out and say, "Hey, go check if the dumpster's full." You can actually get that information automatically when you know the dumpster is full. It's going to send a text, the AI, to the dumpster company and probably to someone who's managing the dumpster on site saying, we've called for a replacement. Right. So again, that, and then you saw the PPE. This will measure PPE as well.
So then the sensor can say, hey, the dumpster is full, and it can send out the message to get it, emptied out. And then when it's emptied out, the sensor can say, hey, it's now emptied out. You can start using it again.
Yeah, absolutely. And again, those are just algorithms that as an owner, they would say, yep, I want to do that. I want that. So the owner will tell us what it is that they want to monitor. So the difference here is that instead of going out and sending people to do it and look at people come in or have a temperature monitor as they walk in, handheld, you no longer need to do that. This information is going to be automatically coming to you. For example, what you're seeing on the screen here, these are Gigapan images. Gigapan images are like a 360 view, but you could zoom in incredibly close and get the detail as if you were right in front of the object. That's another camera that we have on here. The LiDAR scanner is scanning equipment just like any 3D scanner would as well. Again, that's information coming to you. You don't have to send out a crew of 2 people to go scan 10 different locations on a job site. You're getting this automatically. The other side of it is that, you're also using infrared technology not only to measure human temperature, but let's say you wanted to measure pipes. If they get too hot and there's a problem, if it exceeds a certain threshold, someone's going to get a text. This motor is going to fail. It's at this temperature. It's running too hard. Let's text the manufacturer and let's let the building engineer know that there's a problem.
Right. So I guess you could have sensors in the pipes, like temperature sensors, but now you don't need that. You just have one thing and it gathers all that information, and then you can say, hey, watch the temperature of these pipes, and if they go over a certain level, send a warning or even shut down the hot
right, exactly. So
source.
If you look at this screen here, we have the MMIs hanging off the beams. And this actually is a central energy plant where these sensors not only were used during construction, but they're also remaining behind for the owner. So the owner, once the equipment is operating on a daily basis, the owner can keep the MMI and utilize the MMI to continue to monitor the equipment. So if a pipe is getting too hot,
when I see this, I have a question. So here, some equipment is blocking some other equipment. So you have a sensor and you see, but then what if it is behind something?
Right, which is why we have more than one. In this scenario, we have 5 of them.
Those are. I see.
So that way,
I thought this was a view from the sensor, but this is overview, and you're seeing lots of sensors.
There's lots of sensors covering all different areas, and you're right. You want to be able to get as much of the equipment that you want to monitor in sight. And keep in mind, all of these MMIs are working together. Like they know where each other is at, and they're also accumulating all the data and combining it. So
into one model.
So it's all being, controlled, and they all sort of talk to each other. So again, I think this is, you could use this during construction. You could use this, after construction. An owner can keep it in their, for their use. So this actually opens up, the ability for facility management. Facility management is something that is not, very tech heavy in a lot of areas. So again, we just want to be able to get all this information to the field as much as we can. So I want to share with you another slide here, Kai, and I won't bore you with everything.
It's not boring. This is super exciting.
But this screen's a little busy, but if you look at everything that's on the left currently, this is really scanners, security cameras, physical people that are, watching a job site or some kind of security. This is what happens today. And usually if I were to scan something, let's just say, if I were to go out and scan an area that's being built, it's usually a 12 to 24 hour time frame to get it back into the system for somebody to be able to compare that 3D scan to a 3D model and say, oh, the duct's off, or there's something wrong over here, or they're not actually building this correctly. The MMI that we have will bring that information to you, but it will also tell you if there's something wrong. Like, instead of you pulling in a scan model, it's going to say these ducts don't match, or this doesn't match. You know, and it'll do all sorts of different things, but it's bringing the information to you, so it's going to alert you that something is wrong with the scan versus what was coordinated, and then it's going to tell you, here's what the differences are. Or you can pull in the point.
It's bringing it from data to useful information.
Exactly.
Like, that's how I look at it. It's like data, lots of data, and then somehow you have a brain that translate it into useful information.
Exactly. And the time for the information to get from the MMI into a system for someone to look at is 24 minutes the first time. So if it's doing a scan of an area, it takes 24 minutes to process, get into the system for you to view, versus 12 to 24 hours. Then, as it's scanning and as construction's going on, it's only going to pull in what changed, what was installed. It's not going to rescan the whole area. It's going to parse it. So you're only going to get information that changed. So that 24 minutes turns into a matter of minutes at that point. It takes 24 minutes for it to scan the whole time and then for you to get it. But then after that, that time span is much shorter if you're waiting for 3D point cloud data. It's self-registers. So for those of you that are out there that understand what scanning is, a lot of times you have to actually position the point clouds because the systems won't necessarily do them on their own, or the software won't do it on their own. This automatically does all the registering automatically. So there's really no need to go into a model and have to locate it, because all the MMI spatially know where they're located on a job site. So they know spatially where they're at based on a world coordinate system or a coordinate system. So again, that's the difference. And really the goal, Kai, here is to get this information to people as quickly as possible. Get it to a handheld, get it to an iPad, get it to your iPhone, and let them, review it immediately. Now you have the ability to react faster to situations on a job site. And not only that, but this information is coming back into a BIM 360, into a Graphmetrics. It may be linking what you had for documents for an air handler. It's going to pull in where the air handler's at into your system and say, oh, this air handler has arrived on the job site. It's going to also then update you when that air handler is installed. It's going to update your system. The persons who are managing the project are going to know, oh, AC1 is installed. Great. AC2 is installed. If I want to do an earned value assessment of what's built, I can go to my MMI and say, tell me where everything is at from a material standpoint, so I can assess how much money we've spent on the project versus how much money we planned for. And so earned value assessment is something that, many companies are interested in being able to assess, and having these robots out on the job site all the time. From a security standpoint, if you have this in your entrance, and I showed a video of this earlier, you have people coming in. If you have people coming in at 2 a.m. in the morning and they're not supposed to be there, guess what? Someone's going to get an alert. Someone's on site. They're not supposed to be there. Here's a picture of them. Sends to your phone. You react to it. So again, I see this also from a security camera standpoint being also part of that ecosystem. The other part of construction is photos. You want to make sure you have progress photos if you ever need to refer back to how was something installed? Was this installed correctly? Did someone get hurt? Again, this is also providing photos of the progress of the project automatically without even asking to do it. The question is going to be, when you go access it, what date and time do you want to access? Here it is. So there's
it
no.
seems to me that with the sensors you can like grab everything, and then with all those sensors, how many were they? How many sensors?
Right now, there's 10 sensors.
10.
10.
Okay, so with 10 sensors of different technology, types of sensors, so you're getting a lot of data. Now, how do you manage to extract and, like we talked about, turn that into actionable information? That seems to be where it's going to be super hard to make it, being able to analyze that data and make sense out of it and make actionable, useful information.
Well, let's just say you're tracking material, right? And let's say we're using QR codes. The device is going to find the QR code and it's going to capture it, and it's going to automatically feed that information back into the system.
Help me visualize this. A QR code, I'm thinking of a little badge about this size. Am I incorrect? Or do you have like huge ones?
Well, they can be printed different sizes, but yeah, you'd have a QR code on all your material. You'd have maybe an area where all your materials arriving. You may have somebody automatically scanning those as they arrive. And then the MMI will track it at that point.
With a hand scanner, you're thinking?
You do hand scanner, or bring them in an area where the MMI will see what's being brought in, or a hand scanner. There's always someone on site checking in material. They use QR codes today, even, and they track it. But
what I was kind of curious about is if that sensor is way up there, I guess you have a few, and then you're carrying your materials. Will that somehow pick out and search out those QR codes? Or is it more like deliberate?
QR code is a way. There's a company we're talking to. They want to use RFID. There's different ways to track today material, and those are two different ways. The other ways, you have to track material is AI. AI will know that this equipment is a mechanical air handler. And as the AI learns, it's going to be able to differentiate material as time moves on. But the goal is to get all the scan data back into any SaaS system that you want to manage with. So you could say, I want scans every hour. I want this area, I want to see the latest scan every hour. And you're monitoring as construction is being built that day, every hour. Now, granted, that may be too much. You could do daily. But you would set it so you would get that information to arrive to wherever you want it to go. Again, this is information that instead of going out and sending somebody to get that information, this is going to be information that you'll have readily on hand. So you'll be able to go into a system URL and look at all the information, look at all the data that you asked to see at any moment in time. So again, that's really the purpose of the MMI in terms of trying to get that information as quickly as a matter of minutes. So really, it all depends. So what you're looking for. The goal here, Kai, is we want to solve problems. Like what is the information that you want to get today? What are your pain points? And we get the MMI to help solve those problems.
Okay, so let's just we got a few, but could you list some of those problems sort of as it's solving? sort of like a repeat
Sure.
summary.
Yeah.
So just, like what is it solving, So I see lots, right?
So I'm going to call this sort of automated monitoring, and all of these points that you see coming out are points that we're getting from a lot of our prospects and clients. So we want to be able to auto register point clouds. We want 3D scanning automatically. We want volumetric tracking. That came from a mining company yesterday. We want to do gigapan imagery. We want to do employee safety monitoring. We want to know where they're at from a safety perspective.
I like to, all of these are, for me, they're one level down. So from what they're actually solving. So like when this mining company said they want volumetric tracking, what are they solving? 3D scanning. What are they?
Well,
because 3D scanning is like a
tracking
technology.
The aggregate that's being moved and everything that they're mining. And they want the MMI to help support that process, in addition to other technologies too. They have
so they're probably tracking today through some other means, and it's of low quality, or
there's some that use drones,
reduce the cost.
They use drones, but they want this to, they have to go find the data. They want the data to come to them. So tracking volumetric, they just want to be able to find out what happened today and be done with it. They don't want to go out and fly a drone. They don't want to do any of that. They want to place enough of these on their job site to get the information that they need on a daily basis to manage the project.
Right. Okay. So they want to reduce. I'm all about like outcomes. I don't know. So that's, so they want to reduce their effort to track or manage all their information and all the movements on site. Is that?
Yeah. They want to track that. They want to track their vehicles. They want to track their tools. They want to make sure, where everything's at. That's the other piece that I haven't mentioned. If you want to track all of your assets, meaning all your tools on a job site, you could with this. Again, this is really, and I could probably put 20 more things on here that people want to monitor. Some people come to us to help solve their problems. We talked to a concrete company, and they want to use this to be able to monitor their floor flatness when they pour concrete. If we have these fixed, they want to be able to mount these, and they're pouring concrete on a steel deck, and they want to see if the deflection goes beyond a certain threshold, and if it does, they want an alert.
Right.
Those are questions that I would have never asked, but when we present them with what this can do, they'll ask, can this monitor deflection in steel if it goes beyond a 1/4 inch at the stress point? And the answer is yes. We tested it. We have these in a hotel, for example, to monitor people coming in when COVID was such a really powerful thing in some parts of the world, still is, but they wanted to monitor people with temperatures. Then the next question was, and this hotel is a casino, the next question was, can this also detect somebody walking in with a firearm? And we tested it, and the answer is yes, we could find the firearm. Again, these are questions that we would have never come up with, but the main goal here, Kai, is to talk to an owner and figure out where the pain points are. And we could say, yes, we can solve that, or no, we can't solve this. We get asked every day if this can solve certain things. I want to say 99% of the time we can, but there's sometimes there's one that we can't, it's just one of those things where we just couldn't figure out, or maybe it just wasn't applicable with our technology. But for the most part, if we go to an owner, we talked to AECOM, we talked to different companies, Baker Concrete, etc. They all have a different set and series of problems. AECOM conversation was, we build dams. If we set one out on a dam, it's doing vehicle tracking, it's doing people monitoring. But if there's a shift in the concrete, will we know? The answer is yes.
Right. Yeah.
If it, so again, those are questions that before I got into this and before I started talking to companies that are interested, questions that have come up, I would have never imagined some of these questions.
So where are you guys now in the development of this? What stage? Where are you at?
Well, we have one being built. It's under, it's actually being built, and we want to be able to test it. So we have two companies that are very interested in testing this on their job site, and we'll white paper it. We'll do a case study, et cetera, once it's actually completed. And we have two different sets of companies. One's a mining company, and the other one is a construction company that wants to monitor all sorts of aspects from a general contracting perspective.
So that means also the software to do this is...
Yeah, there's a lot of software development. We do have, obviously, AI. There's some deep learning. There's some narrow AI. And a lot of this, has to be developed. All of the, and the other thing I didn't tell you is that we do have 3 patents on this that don't exist in any other device. So those patents already have been submitted and tested, and a lot of the existing technology like 3D scanning, infrared, all of this technology already exists out in the market. It's just a matter of putting it all in one device like this, which there's really not many companies that are doing this all-in-one device. I'm not sure what the reason why, but maybe, sort of we're the first to get to it. There are a few out there that have maybe 2 sensors or 3 sensors, but not with the amount that we have, and nor do they have the ones that we have patented.
And I think, as you explained, that it auto registers, and you put up 3, 4 of these, and I think, for me, the success of this one key element is how easy is it to set up and use. So that helps.
Yeah, our goal is to be plug and play. Allow owners to be able to relocate this, move this to different areas of wherever they need it, and then just plug and play. That's all that needs. Depending on where the information goes, however, if it's tied into their IT systems, then we would have to work with their IT to open up a connector where we can actually feed that data back into their systems if they want to manage this data into their systems. Or we can take it into a SaaS system like Procore or BIM 360. Or we have our own.
Okay.
We have our own URL where you can access that information as well. So It's not dependent on what are you using. We can make it available in any format.
All right. So let's call this a super scanner. I mean, it's like the ultimate scanner, right? Anything else before we leave the scanner that you want to say about the scanner? It's pretty amazing.
It's the people that I'm surrounded with, especially our CTO, his name is Sean Lamont, has been one of the most impactful people in the industry. He was sort of like the inventor of a 3D scanner called 3D Guru back in the late 90s and early 2000s. He sold that technology to Trimble Systems. And we all know what Trimble is. Trimble is probably one of the biggest companies out there with scanning technology. Well, that technology is Sean Lamont's technology. He sold that to Trimble. So the experience that we have here with Sean and his experience with all these different sensors is really powerful. And I just feel it to be a privilege to be around someone like him. And my focus is bringing his knowledge and his ability with sensory technology, with AI, and bring it to the space that I am accustomed to working in, which is construction.
Right.
So my goal is to add efficiency to the industry and help companies be more profitable, and more efficient and more accurate.
You know quite a bit about our company, Graphmetrics, and we talked a little bit about maybe some collaboration. So how could you help me understand, and maybe even more the listener understand, how would this work together with like Graphmetrics TrinPod technology?
Well, Graphmetrics, in my opinion, is really making headway as it relates to the managing and linking of documents. And the way I think about it is, a project manager or a superintendent, part of their job is to manage information. Like, how do they get it? How quickly can they get it? And I've seen studies out there, without any kind of program, sometimes a project manager's time is taking up just looking for information. Sometimes I've heard up to 40% of their time is looking for information. And the goal, I think, is to try to make that amount of time smaller so they can focus and concentrate on what they're really doing, what they're really building, what they're managing their project at hand. In Graphmetrics, with the ability and the AI ability, and I'm really speaking towards the Trinity side of Graphmetrics, is being able to go out and find information and bring it all together into one and present it to the end user. And that can be a floor plan, that could be a submittal, that can be a spec, that could be a part of your drawing, that could be a schedule on the drawing, or eventually it could link our information that we're feeding into Graphmetrics and bring it all together as one. So not only here's what we designed, here's what we spec'd, here it is on plan, here's the 3D model, and oh, by the way, here it is already on site, installed.
Right.
That's what I think, what I think can happen here, because your IP that you have has the ability to easily allow us to bring in information that will correlate to what you're managing and what you're presenting to an owner. And then that information will always live together, even for the future of the building. Hopefully one day facility managers embrace that kind of information to be able to go back and say, oh, when was this air handler installed? How was it spec'd? Let me see a scan of the installation, etc. So that's great information to always have if you're managing a facility. And that, to me, is a space too that we need to really help and support. And they tend to use, they being building engineers and facility owners, tend to use legacy older type systems that are 2D, but they're evolving as well. But this information too can be also useful for them. So from an owner perspective, I think what we're doing even becomes more important for them to track their assets, to value what the designer and engineer are doing, and to value what the general contractor is doing. And he's collected all this great information that now you have easy access to. And really, that, I think, if we can make what the process of building a building much more sustainable, I think we'll make big strides, because I think we all know that construction in general leaves a very, very large carbon footprint. In addition to, it's the most inefficient and most wasteful industry on the planet. So, I think bringing technologies in like Graphmetrics, like IoT USA with the MMI, like everything that we did from the beginning, from BIM to CAD, managing smart data, I think creates an ecosystem that is really ideal, for the next 10 to 20 years.
Yeah. Yeah. I think, we at Graphmetrics definitely want all kinds of sensors, and the MMI from you guys seems to be the most advanced sensor out there. So we're super excited about it for sure. Yeah. So great. Now, what else?
What else?
What else are you passionate about or interested in that we haven't had time to talk about this time yet?
Well, related to the topic or something completely different?
You choose. What are you thinking?
So, if you were to ask me, Raul, what is your first passion? Like what
is it, Raul? What's your first passion?
Well, I grew up playing piano.
Yeah.
I studied 2 years at the American Conservatory in Chicago.
Actually, as we were just started this, my son, which is downstairs, started playing the piano. I was like, oh, should I send him a message to not play right now? But yeah, okay.
Let him play.
Yeah, I let him play.
Yeah, that was I was able to get a scholarship to the American Conservatory, and my major was jazz piano.
Jazz.
So
nice.
I was a jazz pianist. I still play.
Yeah.
And I changed careers because I got to know my professors and realized that it was somewhat of a difficult life, or a different type of life to live as a musician.
Right.
So I changed my career, but that's still my passion. I still love to write music. I still love to play music. I have a lot of material that I've written.
Do you have anything out there? Some, like, we could provide a link and they could listen to some piano music?
I have some early stuff, but I won't give you that link. So
okay. We'll leave that alone.
But some of it, part of it being a musician too, and when you're young and you're green behind the ears, is to make money, you have to go play at some venue, and we had a couple of pop records and things like that. That's the kind of music, but that's not the real music I like to get into. Today, I do have a lot of material. I just haven't published a lot of material. It's like the artist that paints and doesn't really sell his work. I'm sort of like that. Funny. But one thing I will say, Kai, about music is that there's throughout my career, I tend to use music as an analogy of what I do today. And what do I mean by that? If you think about music, music, there's rules, obviously. There's rules of having to be in the right key. You have to be in harmony with certain elements of music. And I think what I do day to day really applies to that kind of harmony and working together, being collaborative, almost like if you're working with an orchestra of musicians. You want to make sure everybody knows their part and everybody's contributing the way they're supposed to contribute. And those simple analogies apply to what I do day to day, almost to the point where I even look at things from a different perspective or a different lens because of my background in music. And I feel that it's really helped me in my career as it relates to how I make decisions, how I work with people, how to be collaborative with people, how to help people. I've done a lot of teaching in music too as well. And, I'm always willing to help someone, evolve as well as a person, and in their journey. So I just have always really, leaned on the rules of music a little bit and apply them in what I do day to day, as well.
Nice.
So I don't tell many people that I'm a musician. So I don't know how many people
So
are going to see this.
Nobody will see it. Don't worry.
Okay.
No, yeah, I always, well, maybe more when I was, as an older gentleman, I wanted to do music, try to, do the guitar, and I'm just terrible at it. But my son, we had him playing violin since quite a young age, and he still plays. He's 16 now. And he just had an interview yesterday with a school where it's like 11th grade. It's like it's a first school that isn't mandatory, like he's finishing that now, and then he has some choice. So for this 11th, 12th, 13th grade, he's applying to music, basically.
Good.
We're all excited about it, and
No,
and I'm with you. It's not like there's no need or desire or thinking that he'll be necessarily a musician. It just seems like such an integrated, great way of learning as you grow up and just get music. He's in the orchestra and he plays the violin and just getting that into the system somehow seems to be, like you were saying, you're just confirming my thought on that. That's just something he's going to have for the rest of his life in whatever he chooses to do.
Absolutely. And to have the creativity of being able to play and write, I think does a lot for you as a person. And I just think
that's what he did on the piano. He doesn't actually play the piano, but he has to go down there and make his own little pieces. He's like,
well, those are his creative juices,
yeah.
Flowing, yeah. And that's always a good thing. I think being creative is important to have, and there's all sorts of ways you can apply creativity, and music is definitely one that I look at has been sort of an outlet for me, is being able to sit down and write music. One of the things I would encourage your son to do is to understand the theory of music.
Hopefully that's what this school will help him do.
Good,
because
yes.
I can't help him.
Well, I learned theory actually when I was at the conservatory. Before then, it was just playing what I would read. And you don't get the understanding when you're just playing what you read. You have to understand why it was written that way. You have to understand what were the rules behind writing this way. And then once you understand the rules and the guidelines of writing music, then the ability to write music is just, it's like the blinders come off.
And then the principles, I'm guessing you can even apply into construction.
Absolutely.
Those,
Absolutely. And I've done quite a bit of that, I don't necessarily share that I'm applying musical philosophy or musical approach to a construction job site, because they're probably going to want to get my head checked or something. But
they're thinking you're walking around whistling.
Right. But there's a lot of truth behind it. I mean, music is a very well structured set of environments. I mean, really, if you think about it, it's all rules based. So there's a lot of structure to it. Now, jazz, obviously, the structure is loose with jazz because there's a lot of what's called improvisation, and improvisation is key to jazz. That's about 70% of jazz is improvising, and you're not necessarily held to the rules. When I was going to the conservatory, I would get extra credit if I actually went to go play at a jazz bar in Chicago. And so I was getting credit if I actually sat in. And all they would give me literally, here's your chord charts, follow these chords. That's it.
Yeah.
There weren't notes.
Nice.
There were chords. And then I would play whatever I wanted within that chord, and within that time signature. So it forced you, like when you to improvise, it forces you to be creative. That's a big part of what I do day to day.
You still have to be within some patterns or rules. So.
You're within some pattern of rules, but the forcing of creativity allows me to respond to situations that might require a quick response or something needs to be resolved. Again, that's all coming from my music background, so I'm glad that I had that in my background, and I'm fortunate that my father discovered that I had the talent at a young age, and he went out and bought me a piano. So
how nice is that?
Yeah,
I really love listening to blues, like old ones, like New Orleans blues type. Okay, so you also you also are part of Construct Metrics, and I'm thinking, like, if because you are not only working with this sensor, you also have some consultancy going on.
I do. Yep.
So what is it that the services that you offer? Tell us about it. So if somebody wants your services, what can you help them with?
Sure. Well, Construct Metrics is really a everything construction design technology consultancy, and what falls under that: building information modeling, Revit, all the associated programs after Revit. You have, if you want to coordinate, you have Navisworks. That's a program that's been around for well over 15, 16 years, that people use, that's rules-based, to check for any clash or any conflict related construction. There's also other programs out there, like there's Revisto. Revisto is actually a very up-and-coming software tool that allows a higher level of engagement of the actual people on the job site. So it's a very powerful tool that is also doing coordination, but makes it easier for job site personnel to be part of the coordination process. So that is really helping as well. But from a consultancy standpoint, I help many companies and I introduce them on how to integrate and implement a transition. And that transition is really doing it from the old way. Like, they never used BIM, they never used 3D. And Raul, how do I do this? Where do I start? I have a project that's all BIM now, and they want us to use BIM, and can you help us? So the answer is yes. And the answer is, usually I'm involved early on helping them. Then I have a team that will step in and actually walk them through the process. Sometimes we're engaged with that particular general contractor from beginning to end, really showing them every aspect of what we're doing to coordinate the project. And then once that happens, then they're sort of walking on their own after that. And if they still want us to engage with them, we do. I've had other clients come to us and said, hey, we just bought this 3D scanner. We don't know what to do with it. You would be surprised at those requests. It's like, oh, you paid, $85,000, $90,000 for the scanner and you don't know what to do with it. So then I'll step in and, I'm pretty, I know the technology, but I would at that point refer them to somebody who scans every day, a professional scanner, and somebody that will take them and hold their hand. And then I take them further into the process and say, okay, now that you scan this space, here's what we can do with this information now. We can model from it, we can compare from it, we can do all sorts of things depending where they're at in the process. One owner in particular wanted to scan what they were building. And their only interest was They were wanting to track all the changes that were being made that were outside of scope. So, that was a need to compare what was being built versus what the scope documents looked like, and do a comparison of what they needed to how they deviated from the original scope. So there's all sorts of different uses. I've even had.
So if people want, are interested, needs your services, how do they best contact you?
Sure. You can go to my website, constructmetrics.com. That's one way to get a hold of me. The other way to get a hold of me is through my email, rgomez@constructmetrics.com. And I'd be happy to respond to any needs or any questions that people may have regarding my consultancy or regarding MMI and IoT USA. IoT USA is a startup that I'm a part of in helping get that technology off the ground and really get that into industry. So that came through Construct Metrics to me and saying, we need your help. We need someone like you that's been in the industry and understands the technology, and how can we tie this into the overall process and workflow.
So I'll make sure we provide a link, probably somewhere below
Sure.
the video.
Yes.
To you as well as to IoT USA if somebody's interested in the scanning technology. Thank you, Raul. Thank you. So interesting to learn not only about your interest in music, but how you came about, in the intersection between construction and technology, the super amazing sensor, the MMI sensor you guys are working on, sounds just amazing, and we're so super excited to see, if there's something we could do together in the future going forward. Absolutely interested in that integration of that sensor.
Yeah, I am too. So we'll definitely be talking.
Yeah, thank you very much. Learning with Gilb, Raul Gomez. Thank you. Take care.
Kai, thank you so much.